Hello guys, in this video we will look into the centripetal force that we had learned before and how can we relate the centripetal force with this chapter gravitation. Okay, how can we use the centripetal force and then take it into our consideration when we are dealing with the topic of gravitation, especially when we are dealing with the motion of planetary objects such as moon, satellite, or any other space orbiting the Earth or other planets. Okay, and then we want to try to find out the speed, the mass, and anything which is related to the motion of this object. Okay, so you may look into your textbook, which is on page 91. Okay, page 91. Okay, like we had know before, okay, a satellite or any other object, moon, such as the moon, okay, it does not any engine to make it move circulating the earth or orbiting the earth. Okay, we have earth. Okay, we have earth, and let's say we have a moon or satellite. Okay, we take it as satellite, just like we had you had been shown in your textbook. It's satellite without any engine. Okay, without any engine, it may move in this circular path. Okay, it will move in this, so in this circular path. So is it possible, although it has no engine? Of course it is possible. Okay, it had been done, so it should be possible. So we try to relate with what we had learned. Okay, how is it possible? Okay, in what term? Okay, so before we look into this further, okay, in 70th century, okay, 70th century, Newton had thought about this kind of motion. Okay, he had thought about this kind of motion. So let's look into what had been taught by Newton. Okay, this is it. This is his experiment. Okay, the top experiment. That means it is not done practically, but by using the theory which he has with him. Okay, so Newton had thought what happened if a cannonball, if he bring a cannon on top of a mountain and then fire the ball at certain speed. Okay, if the ball is fired at a very low velocity, so here the speed is given 1,300 meter per second. Okay, can you imagine the ball is moving with speed 1.3 kilometer? Okay, 1.3 kilometer, or let's make it simple. What about 1 kilometer? Okay, 1 kilometer in 1 second. So that is quite fast. Okay, quite fast. 1 kilometer in 1 second. And let's fire the ball. So the ball is moving in the projectile path. Okay, it will move first and then it will falling to the surface of the earth. And let's try to increase the speed 4 kilometer in 1 second. Okay. Okay, now the distance between the mountain and the point where the ball is fall to the surface, so it is quite far. But still, it is not possible for this cannonball, okay, without any engine, to rotate around around the earth. Okay, let me increase to certain speed. Let's take it as 7,400. What will happen? Is it possible? Okay, without any engine, the ball move or orbit the earth. Okay, now you can see that the ball is moving, okay, without touching the surface of earth. So by using this concept, Newton's come up with this conclusion. So that is, it is possible for any object to move in this circular path without any engine. Okay, so what we just need to do, we need to make sure that this object is fired with a certain minimum speed. okay, with a minimal speed, so that it can have this kind of motion. So in this experiment, I just show you it should be approximately 7,400. Okay, 700, 4,000, 7,400. But of course, we can calculate this requirement or this minimum speed. So let's look back into our textbook. Okay. So the radiation of Newton is now a reality with so many man-made satellites orbiting around the Earth without being driven by any thrust. So the satellites has no engine. Okay. Satellites always experience gravitational force acting to the center of the Earth. The gravitational force on satellite act as centripetal force. Okay, now let's relate this motion. Okay, the motion of the satellite. So we had before this we had learned, okay, when a person holding a hammer, okay, and then it is always attached to the center of the motion, okay, center of the motion with a string or cord. So we have string or cord. So that's mean it has centripetal force. Okay, why do you say that this object has centripetal force? Because, okay, it moves in circular path and always accelerating. Okay, accelerating by changing its direction continuously. Okay, continuously. So we see that it should have centripetal force, and the reason behind this centripetal force is the tension in the string between this object and this person and this person. What about this kind of motion when we try to deal with satellite or any other planetary object outside the atmosphere of the Earth? We don't have any string that attach the object with the center of Earth. Okay, the moon, we don't have a string attach the moon with the center of the Earth. So what is the cause? Okay, the cause of the centripetal force here. So what is the cause or the reason behind the centripetal force here? There must be the reason, okay, the cause of the force. So in this kind of motion, we can see that, okay, there is no other forces that make this object move in this kind of path except the gravitational force. So now we can relate the centripetal force with the gravitational force. Okay, so that is how the relationship. That's how can we improve or can we prove the relationship between gravitational acceleration with the centripetal force. So that's mean for any object moving on a circular path, okay, outside the atmosphere of any planet, any stars, okay, we can relate the speed, okay, the speed with the distance, okay, with the distance of this object or this planet, okay, by equating these two equations. First, the centripetal force, it should be equals to the gravitational force. Okay, so this is the distance between center to center, r. M, small m here is the mass of this planetary object, and this capital M is the mass of the planet or mass of the stars or mass of the galaxy or the main object, okay, that being revolved. Okay, so in this case our capital M is the mass of Earth. Okay, in this case, the capital M here is the mass of Earth. Okay, when the satellite orbiting the Earth. So I think that's all for uh, for 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 investigating the relationship between the centripetal force with the gravitational force. Okay, so thank you.